Architectural Builder's Supply is pleased to present you with this recording of the technical question that is listed in the title of this video.
This call may be monitored and recorded for quality assurance.
Let's see what part number it was. It's the SP1000X power supply.
Okay.
And what's happening is when it's double clicking, double throwing, and so it doesn't, it's not operating and won't lock. And so my question is, I'm wondering, is there a distance, maximum distance? Is the power supply too far away, or do I have a bad power supply?
Yeah. So how was it ever working?
Well, I don't know that. It's on a punch list, and who knows how long it's been ignored, and they just now check it, right?
Yeah.
So I can't answer that.
Okay. Well, it's really helpful to know that stuff because it allows us to know the answer. I went to a job site one time, and for the exact reason, I said, How long has it been working? It's like, it's been fine for 2 weeks. I'm like, oh, that's weird. So I go to the job site, and I'm looking around the opening after I'm diagnosing it, and I'm trying to figure out, where's the power supply?
Right.
So I asked someone there, and I says, where's the power supply? He says, I don't know what that was. He's like, but I can tell you there was some construction around this door, and they moved a metal box 500 feet further away. So voltage drop. So that's an easy test, right? All you got to do is present your credential with your voltmeter on the load and see what it's giving you. And if you're 10% lower than what you need, voltage drop is the problem. Or there's a short.
Right.
Or not a short, but there could be an open, or there could be some problem. But you'll be able to measure ohms, and then you'll know, if you know the ohm value of what's there, then you can determine whether or not you're trying to suck too much through too small of a straw.
Right. I've looked at the circuit board, and it looks nothing out of the ordinary, right? So I'm wondering if it's voltage drop, and I just wanted to, before I go measure all that, make sure I wasn't barking up the wrong tree.
Yeah, I don't think you are. I think it's, especially if it's never worked or if there's been some change, but definitely take your multimeter when you go.
Okay. You've been awesome. Thank you very much.
Thanks for calling. Bye-bye. Architectural Builder's Supply hopes you have enjoyed this program. Before we move on, let's have a little discussion what voltage drop is. So I think of there's a table, I think of the table in the Von Duprin catalog. From our site, if you click on manufacturers, you can then search for Von Duprin. You'll find Von Duprin, and then the catalog I like to click on is Electrified Hardware Overview. And then you can just do a find function or Control F on your keyboard for drop. And here is that worked. It wasn't the right way that I used they're using the term. The bottom line is this. I had mentioned about the distance. Well, it's really important to know that when you have distance from the load, the distance between the power supply and the load is important to know in terms of a wire gauge. So if you're trying to push up to a half amp up to 100 feet, 18 gauge wire is fine. You get out to 500 feet, and that strike it was a 1 amp power supply, 16 gauge, and is what the wire gauge needs to be for that 1 amp power supply. What I had mentioned on the phone is it wasn't working. Well, most likely what they did was simply take 18 gauge wire, which would have worked here, but when they moved it 500 feet away, you needed a greater gauge wire, and that would absolutely contribute to what I witnessed in the field of it simply working intermittently at best is actually what happened. So this table is handy. Depending on how many amps you need to push, the wire diameter will get greater, the gauge of the wire will get greater depending on the length. NR means not recommended. Let's take a look at SDC. They too will have wire gauge size and distance chart is what that was. Let's go back. SDC wire gauge size and distance chart. So here's more information, a bigger table really. Von Duprin has tested their information, as has SDC. So let's say that strike was 24 volts. They have different charts for 12 or 24 volt, and if you study it, you'll see that it is that they are different, not substantially, but as volts go up, resistance goes down, and that's because of E equals I times R. E is voltage, I is amperage, and R is resistance. So that simple E equals I times R, that simple algebra, when you change something to the left of the equal sign, something on the right side of the equal sign is going to change inversely, most likely, and that's what's happening here. So if you have lower volts, your amperage is, your resistance is going to go up. So it would be logical to say that in a 24 volt versus 12 volt system, because the resistance is lower when the volts are higher, 16 on a 4 amp, and over here for sure it's 14 gauge. 16 gauge for 4 amp, 16 gauge for 5 amp. 4 to 6 they want 14 gauge. So you've got more resistance occurring in a lower voltage. So the point of the matter is you can study this. So in the initial installation, a 1 amp power supply, and it was within 25 feet, 20 gauge is all they're telling you that you need. But when they moved it to 500 feet, there's nothing on the chart, according to SDC, for that application. There's nothing on the chart. So you're going to want to follow this. When you're always thinking about distance when it comes to power supplies. There's science behind all of this. I would have to restudy it so that I could explain it. I don't recall it. But the table is the culmination of the study. So refer to these documents, and you'll be in good shape. Let's move on to the rest of the video. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. So the double clicking, it's hard. I don't actually know what double clicking refers to. I've got the installation guide here, and it really seemed like voltage was an issue. And I'm looking in the manual for any reference to double clicking or troubleshooting. Well, there is troubleshooting in terms of the LEDs. If you've got a problem with the AC voltage, the green, the ground wire, it'll give you a slow blink. Right there. So on the outputs, trouble relay output indicating low DC output voltage. So you've got 2 delayed follower normally open relay outputs rated at 0.6 amp 28 volts. Delay time is selectable, half or 1 second. Energized duration is 1 second. That very likely is the double clicking that he's hearing. If you're getting insufficient voltage, yeah, I would think that your outputs are going to say, hey, I'd love to help, but you got to give me more. So, and because the fact that the client said that tells me that he probably already knows that it is the problem. So I had said you got to check for voltage. So what you're going to do, this is just a really inexpensive meter, and I don't have any simple way, quick way. I'm lazy today. I'm lazy every day. To tell you what the voltage is. I could get a power supply, I could get some wires, I could put some resistors, and I could show you that it won't say, 26.1, 24 volts plus or minus 10% is what we're looking for. So you're going to set it to DC voltage, and it's 24 volts is what this is. I don't think this runs at, well, you got to be careful, either 12 or 24 volts. If it's 24 volts, you're going to set this range to the next highest voltage that you would expect to see. If it's 24 volts, you're not going to expect to see 2 or 20. You would expect to see the next highest range, which is 200. If it's 12 volts, just click it down to 20. Doesn't really matter. It just basically refers to what the value is going to look like up here in terms of decimal points. It doesn't matter. When you put your leads onto the load, or in this case on the output relays, and you present the credential, meaning you're energizing that relay, you're going to know if it's not 24 volts plus or minus 10%, it's a problem. I had also said there could be a problem if what was in there was shorting or open. Not open. Open you would get infinity, but a short where the windings, or if it's a solenoid or something, is causing it to ask for too much amperage. I suppose that may or may not work, but if you know the ohm value of what you're testing, you can easily convert this over to ohms and then test that. If you know the known ohm value of a motor, you can easily present the credential, make the motor spin, put your leads on there, and you'll know immediately if you're within range of the published ohm value. Okay, but testing for voltage is the easiest thing. What happens is, and that job site I referred to, is I went out there, and what they actually said was, well, it works sometime, and I know that the material, it was all installed for about 2 weeks, is the bottom line. And they called, and it was worked for about 2 weeks, and it was the employee entrance to a 3 shift a day manufacturing facility. So employees had to get in, because they not only had to get in the door, but it was also clocking them in and out. So it was causing a lot of havoc. And what was happening was it was intermittent. It would work sometimes and not other times, and that could also make sense. And they call Saturday at like 2 o'clock, and it was a 45-minute drive to go there, because I said, well, I'll go look at it. It's not terribly far. So I go out to the job site, and I realized it was a Hess strike, and that 1006 that they had installed had the gates, the triggers that allowed it to work. There was one at the top and one at the bottom, and when they both opened, the keeper would open. Okay? They both had to open, and what was happening was the bottom was, when the circuit was closed, the bottom would fall open because of gravity, and the other would sometimes open, allowing the door to get pulled open sometimes. So I've got my voltmeter. Pardon me, I didn't have a voltmeter with me, and in fact, I didn't know how to use one at that time. So I go out there and I realize, okay, yeah, it works sometimes and it doesn't other times. Okay, what's going on? So I says, well, where's the power supply? Let me look at the power supply, grasping for straws. And I looked up, and it's 20-foot ceilings, and I realized there's no power supply here. Where are the wires going? They go up the wall, and they go 100 feet down the one wall, and they disappear somewhere in the back. So I'm literally walking through hundreds of feet of this warehouse. And I finally asked someone, where's the power supply? I don't know what that is. Well, there should be a metal box that's bringing the electricity to the opening. Oh, yeah, we moved that because it was in our way. And I says, where'd you move it to? To the under end of the warehouse, and I kid you not, it was 500 feet. I didn't need a voltmeter to tell you that it's not going to work, because the amount of voltage that you're going to get at the load is dependent on its distance from the source, the power supply. It's also dependent on the diameter of the conduit, of the conductor. Thicker wires will allow you a longer distance. Thinner wires won't. It's kind of counterintuitive. But a thicker wire has more copper to allow the conductivity of the movement of the electrons through the conductor. A thinner wire constricts it. So when I said it's like sucking too much out of too small of a straw, The small straw is the constricting force there. And I hope that sheds some light on the mystery to the extent that I'm attempting to shed light on the mystery. Thank you very much. Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.